Hello, good morning students. Myself Anurag Shukla and I am going to teach you area related to the circle, class 10th. There are 7 topics in this chapter. First is the locus of a point, second is the definition of circle, and third is the perimeter and area of circle, and fourth is the sector of a circle, fifth is the segment of a circle, and sixth is the area enclosed by two circles, and seventh is some useful results. First point, locus of a point. Locus of a point. Locus of a point is the path traced by point during its motion. Means if a point is moving, then it releases a path behind its motion. That path is known as the locus of a point. Second point is definition of a circle. Circle. What is a circle? Circle is a locus of a point on a plane whose distance from a fixed point is always remains constant is called circle, and fixed point is known as the center of a circle, and the constant distance is known as a radius of circle. In other words, we can say that the collection of a point on a plane whose distance from a fixed point is remains constant is called circle. Here, a figure of a circle is represented in the form of figure. There is a point P which is moving around a plane in a plane on a plane whose distance from a fixed point O is remain constant, and this constant distance OP is the radius of a circle is small r, and circle can be represented in the form of C in a small bracket center O and radius is small r. Now third topic is perimeter and area of circle. Perimeter of a circle. The perimeter of a circle is the length of its boundary. The unit measurement of perimeter of a circle is centimeter or meter. Perimeter of a circle is also known as circumference of a circle, and perimeter of a circle is equal to 2 pi r, where small r is the radius of circle. Now the area of a circle. The area of a circle is a measurement of region enclosed by its boundary. It is measured in centimeter square and meter square or meter square. Okay, or meter square. Or meter square. Area of circle is equal to pi r square, and r is where r is small r is the radius of circle, and pi is an irrational number, and the value of pi is approximately equals to 3.14 or 22/7, because any irrational number has no fixed value. It has always approximate value. Now fourth topic is sector of a circle. Sector of a circle, the part of a circle which is inclined between two radii of circle is called sector of a circle. If the arc of sector is small, then sector is minor sector, and if the arc of sector is large, then the sector is major sector. Area of sector OAPB is equals to theta, the angle between the two radii theta, upon 360 degree, the whole angle created at the center of circle into pi r square, area of circle. Length of an arc of sector OAPB is equals to length of arc AB is equals to theta upon 360 degree into 2 pi r. Our perimeter of a sector is equals to 2 times radius plus length of the arc AB. That is equals to 2 pi 2r plus theta upon 360 into 2 pi r. Now the fifth topic is segment of a circle. Segment of a circle, the part of a circle formed by section of circle with the chord of circle, which divide the circle into two parts. The bigger part is known as major segment and a smaller part is known as minor segment. Now, area of minor segment is segment APB, APB, this sided portion is equals to area of sector OAPB, OAPB minus area of triangle OAB. Similarly, area of major segment AQB is equals to pi r square area of circle minus area of minor segment. Note, area of triangle OAB is equals to 1 by 2 r square sin theta, and theta is the angle between the two radii of circle. Here, major sector and minor sector of the circle can be represented in the form of figures. Here, a chord AB intersects the circle and and divide it into the two parts. First part is a major segment, which is the bigger part of the circle, and a smaller part is a minor segment of the circle. It is area enclosed by two circles. If capital R and small r are the radii of two concentric circles, such that capital R is greater than small r, then area enclosed by the two circles is equal to pi capital R square minus pi small r square. Here are the two concentric circles. First is the radii of their circles are capital R and small r. Then the area enclosed then the area of shaded region is equals to the pi capital R square minus pi small r square. Means the area of bigger circle minus area of a smaller circle. Now, the seventh and last topic of this unit, this chapter, some useful results. Some useful results. First point of this point, if two circles touch internally, then the distance between their centers is equal to the differences of their circles, their radii. Means if two circles are intersect, two circles are touches each other internally at a point A, then the distance between their centers O dash is equals to radius of bigger circle OA minus radius of smaller circle O dash A. That is distance between their centers O dash is equals to OA minus O dash A. Second point is, if two circles touches externally, then the distance between their centers is equal to the sum of their radii. This means there are two circles which are touches each other at externally at point A. Then the distance between their centers O dash is equal to the sum of their radii OA plus O prime A. This means O prime is equal to OA plus O prime A. Now the third point is distance moved by the rotating wheel in one revolution is equal to the circumference of the wheel. Now the fourth point is the number of revolutions completed by a rotating wheel in 1 minute is equal to the distance moved in 1 minute upon circumference of circle. The radii of two circles are 19 centimeter and 9 centimeter respectively. Find the radius of circle which has circumference equals to the sum of circumferences of these two circles. To solve this question, first we consider the radius of the required circle be x centimeter. So let the radius of a required circle be x centimeter. Now the circumference of, now according to the question, to question, the circumference of circle equals to the circumferences of the sum of circumferences of given two circles. That is 2 pi x is equals to 2 pi r1 plus 2 pi r2. 2 pi x is equals to 2 pi bracket में r1 plus r2. 2 pi is cancelled out by 2 pi and x is equals to r1 plus r2. For the value of r1 and r2, x is equals to 19 plus 9, that is x is equals to 28 centimeter. It is the answer. The radii of two circles are 8 centimeter and 6 centimeter respectively. Find the radius of the circle which has area equals to the sum of areas of two circles. To solve this question, let the radius of required circle, let the radius of required circle be small x centimeter. Then according to the question, area of required circle is equals to area of sum of the areas of given two circles. Areas of given two circles. That is pi x square, pi r1 square plus pi r2 square, pi x square is equals to pi bracket में r1 square plus r2 square. Pi is cancelled out by pi. X square is equals to r1 square plus r2 square. Put the value of r1 and r2. 8 square plus 6 square. X square is equals to 64 plus 36. That is equals to 100. X square is equals to, so x is equals to 10 centimeters. It is the answer. Now third question is, Find the area of sector of circle with radius 4 centimeter and of angle 30 degree. Also find the area of the corresponding major sector. Now, given that the radius of circle small r is equals to 4 centimeter and angle theta is equals to 30 degrees. So, area of minor sector is equals to theta upon 360 degree pi r square. Put the values of theta and small r and phi. Theta is equals to 30 upon 360 degree into 3.14 into 4 into 4. 12 times 4 3 is 12, 4 1 is 4. 12.56 upon 3, 4.119 centimeter square. Now, area of major sector is equals to pi r square minus area of minor sector. That is equals to 3.14 into 4 into 4 minus 4.19. It is equals to 5 centimeters square.